From the discovery of electricity to the smartphones that connect our world, electronics have revolutionized how we live, work, and communicate. In this journey, we'll explore groundbreaking inventions and their pioneers, tracing the timeline of electronics from the 17th century to today. Let's dive into the sparks that ignited this transformation. In 1600, English physician William Gilbert published De Magnete, distinguishing electricity from magnetism. He coined the term electricus from the Greek word for umber, which generates static electricity when rubbed. His experiments with lodestones revealed Earth's magnetic field, laying the foundation for electrical science and inspiring future inventors. In 1780, Italian scientist Luigi Galvani discovered bioelectricity when he observed frog legs twitching under electrical stimulation. His work showed that living tissues could conduct electricity, sparking debates about animal electricity and inspiring Alessandro Volta to develop the first battery, a cornerstone of electronics. In 1800, Alessandro Volta invented the Voltaic pile, the first battery, using stacked zinc and copper discs separated by brine-soaked cloth. This device provided a steady electric current, enabling experiments in electricity and powering early telegraph systems, marking the dawn of practical electronics. In 1820, Danish physicist Hans Christian Ørsted discovered that an electric current creates a magnetic field, demonstrated by a compass needle deflecting near a current-carrying wire. This breakthrough in electromagnetism influenced Faraday's work and became essential for motors, generators, and modern electronics. In 1831, Michael Faraday discovered electromagnetic induction, showing that a moving magnet could induce an electric current in a coil. This principle underpinned the development of generators, transformers, and electric power distribution, forming the backbone of the electrical engineering revolution. In 1837, Samuel Morse developed the telegraph and Morse code, a system of dots and dashes for transmitting messages over long distances using electrical signals. The telegraph revolutionized communication, enabling instant messaging across continents and setting the stage for global networks. By 1866, the transatlantic telegraph cable, led by Cyrus Field, connected Europe and North America. This underwater cable, made of copper and insulated with gutta-percha, transmitted Morse code across the Atlantic, shrinking the world and laying the groundwork for global telecommunications. In 1876, Alexander Graham Bell patented the telephone, converting sound waves into electrical signals for transmission over wires. His invention enabled real-time voice communication, transforming personal and business interactions and paving the way for modern telephony systems. Thomas Edison's 1879 incandescent light bulb used a carbon filament to produce reliable electric light. While others worked on similar ideas, Edison's design was commercially practical, illuminating homes and cities and driving demand for electrical infrastructure worldwide. In 1888, Heinrich Hertz proved the existence of electromagnetic waves, transmitting and receiving radio waves using a spark gap generator. His experiments validated Maxwell's theories and enabled wireless communication, directly inspiring Marconi's radio innovations. In 1895, Guglielmo Marconi developed wireless telegraphy, sending Morse code signals through radio waves. By 1901, he achieved transatlantic wireless communication, revolutionizing maritime and global communication and laying the foundation for radio broadcasting. In 1897, Carl Ferdinand Braun invented the cathode ray tube, a device that displayed electrical signals as light on a phosphorescent screen. The CRT became essential for oscilloscopes and early television displays, shaping the future of visual electronics. In 1904, John Ambrose Fleming invented the vacuum tube diode, a two-electrode device that rectified electrical signals. Used in early radios, it marked the birth of electronics by enabling precise control of current, a precursor to modern semiconductor technology. In 1906, Lee De Forest invented the Audion triode, adding a third electrode to the vacuum tube for signal amplification. This breakthrough powered early radio broadcasting, telephone systems, and computers, making it a cornerstone of 20th-century electronics. In 1926, Japanese engineer Kenjiro Takainagi demonstrated the first electronic television, using a CRT to display images transmitted electrically. His work preceded commercial televisions, influencing the development of broadcast media and visual entertainment worldwide. In 1948, John Bardeen, Walter Brattain, and William Shockley at Bell Labs invented the transistor, a compact semiconductor that replaced bulky vacuum tubes. Its reliability and small size enabled modern computers, radios, and countless electronic devices. In 1958, Jack Kilby at Texas Instruments created the first integrated circuit, combining multiple transistors and components on a single silicon chip. This invention miniaturized electronics, making complex devices like computers and calculators feasible and affordable. Theodore Maman's 1960 Ruby laser produced a coherent beam of light, a breakthrough with applications in telecommunications, medical surgery, and data storage. Lasers became integral to fiber optic systems and precision manufacturing in electronics. In 1962, Nick Holonyak at General Electric invented the first visible light-emitting diode, LED. Its energy efficiency and durability revolutionized displays, lighting, and electronic devices, from calculators to modern smartphone screens. 1966, Charles Cow and George Hockham proposed fiber optic communication using glass fibers to transmit data as light pulses. Their work enabled high-speed internet and global telecommunications, earning Cow a Nobel Prize in 2009. In 1971, Federico Fagin, Ted Hoff, and Stanley Mesa at Intel developed the 4004, the first commercial microprocessor. This single-chip CPU powered early computers, calculators, and appliances, ushering in the era of personal computing. Throughout the 1970s and 1980s, microprocessors powered the development of personal computers and consumer electronics. Apple and IBM led the market, making computing accessible at home and work. This marked a significant leap toward digital lifestyle. In 1983, Martin Cooper's team at Motorola introduced the Dynati AC, the first commercial mobile phone. Weighing nearly 2 pounds, it enabled portable voice communication, paving the way for today's ubiquitous smartphones. In 2008, R. Stanley Williams at HP Labs developed the Memristor, a memory resistor theorized by Leon Chua in 1971. With potential for non-volatile memory and neuromorphic computing, memristors promise to advance AI and electronics. From William Gilbert's Electricus to the iPhone and memristor, electronics have transformed our world, connecting people, powering industries, and driving innovation. As we look to the future, quantum computing and beyond promise to continue this electrifying journey.